Okay, the last example I wanted to look at in 1.3 is this example for linear depreciation. It's a word problem. It says a company constructs a warehouse for $1,725,000. The warehouse has an estimated useful life of 25 years, after which its value is expected to be $100,000. Okay, write a linear equation giving the value y of the warehouse during its 25 years of useful life. It says let t represent the time in years. Okay. Well, what's kind of difficult to get going on in this problem is that they're really giving you 2 points, and they're asking you to find the equation of a line. Okay, and in this case, our ordered pairs really aren't x and y. They're t, which represents time, and y, which represents the value of this building. Okay, so right away they tell us one ordered pair. They say this building was constructed for $1.725 million. So in year 0, okay, the number of years after construction, well, when it was constructed, it's been 0 years, right? The value is $1,725,000. Okay, so that's an XY pair, or in this case, a T, Y pair. Okay, no big deal. I'm just calling X T basically because it represents time. Okay. So there's another ordered pair they give us, and you might be able to guess what that is, because they tell us 25 years later, okay, after it's 25 years old, okay, so t is 25, the value is 100,000. Okay, so for 25 years, a warehouse goes through a lot of use, a lot of disrepair, and probably isn't worth quite so much. So these are the 2 points on our line. We need to find the equation of the line. Okay. And I'm just going to do exactly what they ask. The y-coordinate is the value, the t-coordinate or the x-coordinate is time. So we just need to use this point-slope formula. Y minus y1 equals m times, well, actually in this case it's t minus t1. Okay, it's not a big deal to call the variable t, but it's in place of the old x variable. Okay. So what do we need to compute here? Well, a couple of things. First of all, we need slope. So slope is going to be the difference in y-coordinates okay, 1,725,000 minus 100,000 over the difference in x-coordinates. Okay, 0 minus 25. Okay, so again, notice that I call this my second y-coordinate. This is my first x-coordinate or y-coordinate. So this would have to be my second x-coordinate, my first. Okay. These belong to the same ordered pair. These belong to the same ordered pair. Okay. Now, in a word problem, it's kind of assumed that you can use the calculator to get an answer if it turns out to be a decimal. But I'm going to go ahead and figure out what this is on my calculator. Okay, and I get actually negative 65,000. Well, that's the slope of this line we're going to find. Okay. Well, now to get the equation of the line, I just need to plug a t-y ordered pair into this equation for t and t1 and y1. So I'll probably choose this one because t is a lot smaller here, but it's going to be y minus the y-coordinate equals m, which is negative 65,000 times x, or t, I should say, minus the t-coordinate of this point, which is 0. Okay, well that makes it a little bit easier. And in any case, if I multiply everything out, basically I'm just going to add this number over. Okay, I'll get y equals negative 65,000 t plus 1,725,000. Okay, so that's the final answer. And again, this line does something useful. It predicts the value of this building t years after it's constructed. When t is 0, the y value is going to be 1.725 million. When t is 25, the y value is going to be 100,000. Okay, so if you want to look and see the value of this building in 10 years, you would plug 10 in for t, and you'll see, I think the value is going to be around $1 million, maybe a little bit more, but that's the use of this formula. Okay.